fx comma g of x are two differential functions and f of 1 equal to g of 1 equal to 2. Then limit of f of 1 g of x minus f of x into g of 1 minus f of 1 plus g of 1 divided by g of x minus f of x as x tends to 1 is equal to. That is the question asked here. Student, here f and g are the two differentiable functions means what? Their derivatives can be found. And the value of f of 1 and g of 1, they are equal to 2. So when they are equal to 2 means what? Here f of 1 and g of 1 are there. They play a role of constant. So that means now let me differentiate now. Limit of, now f of 1 is kept constant, and what is the derivative of g of x? It is g dash of x minus, once again g of 1 is constant, and what is the derivative of f of x? F dash of x minus derivative of f of 1 is 0, and similarly derivative of g of 1 is 0, and divided by here derivative of g of x is g dash of x minus derivative of f of x is what? F dash of x as x tends to what? X tends to 1. Now let me replace the value of f of 1 and g of 1. That's equal to limit of now f of 1 is 2 and into g dash of x minus g of 1 is 2 and into f dash of x, and divided by what is denominator here? G dash of x and minus f dash of x as x tends to what? X tends to 1. Now in the numerator, that is 2 is constant, that is limit of 2 into the bracket g dash of x and minus f dash of x, and divided by denominator g dash of x and minus f dash of x as x tends to what? X tends to 1. Now these two terms get cancelled. After cancelling, we are left with 2, that is 2 is the limit of this function. Is there any option? The second option is the answer. Now students, let me explain this once again. F and g are the differentiable functions, means their derivative can be found, and f of 1 and g of 1 equal to 2, means here f of 1 and g of 1 are there, so they play the role of constant. Now then limit of this function is equal to the question asked. Now let me apply the L'Hopital rule here, because when you put x equal to 1, g of 1 and f of 1, they have the same value comes to 2, so therefore it is coming 0 upon 0 form. Apply the L'Hopital rule. F of 1 is kept constant, derivative of g of x is g dash of x, minus g of 1 is constant, derivative of f of x is f dash of x, minus derivative of f of 1 is 0, and similarly g of 1 is 0, divided by similarly g dash of x and minus f dash of x. Now let me replace the value of f of 1 and g of 1, thereby 2. After this, in the numerator 2 is constant, 2 into the bracket g dash of x minus f dash of x divided by g dash of x minus f dash of x. Both of these two are getting cancelled. That is equal to 2 is the answer. Which one is the second? Third option is the answer. Now the next question is, student, limit of x into sine of x minus greatest integer x divided by x minus 1 as x tends to 1, where this is what? Greatest integer x, greatest integer function. Okay, now the limit of this function, the first one is a 1, and the second option b minus 1, and the third option c is infinity, and the last option it is does not exist. Students, once again here we have come across the greatest integer function. You know very well that generally in case of greatest integer function, limit does not exist. Now as the limit does not exist means, first here put x equal to 1 here, 1 minus 1, that is 0, so use the L'Hopital rule. So by using the instead of L'Hopital rule, now let me calculate the left hand limit and right hand limit. LHL is equal to limit of f of x as x tends to 1 minus, that's equal to limit of it is x and into sine of x minus greatest integer x and divided by x minus 1 as x tends to 1 minus. Student, here x tends to 1 minus means what? Less than minus 1. Less than minus 1, what is the less than 1? What is the greatest integer here? That is limit of, now I am keeping this x as it is, and into sign of less than 1. Less than 1 integer is what? 0. So that is x minus 0 and divided by x minus 1 as x tends to what? X tends to 1. So that is equal to here 1 and into sign 0 divided by 0. That means 0 divided by 0. So that is does not exist. Students, here left hand limit of this function does not exist. So when one of the limit does not exist means what? The answer comes to does not, limit does not exist. Even then, for your purpose, I am going to calculate the right hand limit. I mean, actually it is not necessary to calculate right hand limit because already one of the limit is not existing here. That means the whole limit is not existing. So the limit RHL equal to limit f of x as x tends to 1 plus is equal to limit of x into sine of x minus greatest integer x and divided by x minus 1 as x tends to 1 is equal to limit of, now x as it is, sine of x as it is. Next here the value greater than 1 without crossing 1. That means the integer greater than 1 without crossing 1 is 1 itself. So x minus 1 and divided by x minus 1 as x tends to 1. That's equal to, this is 1. Now suppose if you put x minus 1 is equal to theta, then what happens here? It is sin theta upon theta as theta tends to 0 is equal to 1. That's equal to 1. So what is the right hand limit of the function? Right hand limit is 1. So that is LHL is not equal to RHL. So therefore limit of this function does not exist. Student, actually this part is not necessary to calculate. After this straight away you can come to the conclusion that limit does not exist. Now limit of, see the greatest integer sine of greatest integer x minus 3 divided by once again greatest integer x minus 3, okay, as x tends to 0, okay. Once again this is greatest integer, okay. Then the limit of this one, first option is 0 and the second option is 1 and the third option does not exist, and the last one is sine 1. Now let us see what the answer. Student, here greatest integer means does not exist. Now even then we will calculate here LHL equal to, be very particular about this one, limit of greatest integer sine of x minus 3 divided by greatest integer x minus 3 as x tends to 0 minus, okay. Now 0 minus means what? Less than 0. Less than 0, take one value. Say for example I am taking minus half. Minus half minus 3 means what? Minus 3.5. What is the integer greater than minus 3.5? It is minus 4. So that means limit of greatest integer sine of it is minus 4 and similarly divided by minus 4 as x tends to 0. Let me repeat once again. Give some value less than 0. Say minus half I will take. Minus half minus 3 is minus 3.5. The greatest integer without crossing minus 3.5 is how much? Minus 4. Divided by minus 4. Divided by minus 4 is there. For your information, this is minus 3. This is minus 4. So our minus 3.5 is here. That means your journey is coming up to here, minus 3.5. But without crossing this value, what is the integer? This minus 3.5 is not integer. So you are coming back to the 4 minus 4. So that is sine of minus 4 divided by minus 4. That's equal to now limit of now greatest integer sine 4 divided by 4 as extends to what? Extends to 0. Now let me see what is the value of sine 4. Student 4 and pi by 2, and now we shall see what is the value of pi. Pi is equal to 3.142. Now shall I write here pi by 2 is less than 4 and 4 is less than 3 pi by 2. The value of pi is 3.142. So half of that, or even you can take it as upon 4 you want here, that is a sine pi by 2, or you can take a sine pi and 3 pi by 2. Let me take here pi is less than 4 and 4 is less than 3 pi by 2. So now here the value of pi is how much? 3.142. 3.140 is less than 5. Now I am applying the sine function here. Sine pi is less than sine 4 and sine 4 is less than sine of 3 pi by 2. Student, what is sine pi value? 0. And similarly divided by 4 is there. See, pi is less than 4, 4 is less than 3 pi by 2 is there. So now sine function you apply. Sine pi is less than sine 4. Sine 4 is less than 3 pi by 2. What is sine pi value? 0. Is less than sine 4 is less than minus 4. Student, upon 4 is there. I am taking upon 4 and upon 4. So the integer less than minus 1 by 4. The integer less than minus 1 by 4 is equal to how much? Minus 1. So the left hand limit of this function is minus 1. See, this is a very important step here. Similarly, RHL is equal to limit of the greatest integer sine of x minus 3 and divided by greatest integer x minus 3 as extends to 3 plus. That's equal to limit of it is greatest integer. Now extends to 0 plus means greater than 0 without crossing 0. What is the integer here? Greater than 0 without crossing 0 means 0 itself. So I am getting a sine of minus 3 get and divided by minus 3. Okay, as extends to what? Extends to 0. So that is equal to limit of greatest integer. What is sine of minus 3? Minus sine 3 divided by minus 3 means what? It is sine 3 divided by 3 as extends to what? Extends to 0. Now let me take the same inequality here. 3 is there. Shall we take a pi by 2 is less than 3. 3 is less than pi. The value of pi is 3.142. So pi by 2 is less than 3. 3 is less than pi. Now apply the sine function. Sine pi by 2 is less than sine 3 is less than sine pi. Is it clear, step? Sine pi by 2 is less than sine 3. Sine 3 is less than sine pi. What is sine pi by 2 value? 1 is less than sine 3 is less than sine pi 0. And upon 3 is there. That is 1 upon 3 is less than sine 3 upon 3 is less than 0. That's equal to 0. So what is the integer less than, that is the less than 0. So that means sine 3 upon 3 is equal to how much here? 0. So the right hand limit of this function is 0. And what is the left hand limit? Left hand limit is minus 1. So LHL is not equal to RHL. So therefore limit of this function does not exist. I think this example as well as the previous example, both of these two, I hope you understood examples. Now let f of x equal to sine x if x is not equal to n pi, and it is 2 if x is equal to n pi, and where n belongs to I, and g of x is equal to it is x square plus 1 if x is not equal to 2, and it is equal to 3 if x is equal to 2. So this is f of x value, it is g of x value. Then limit of g of f of x as x tends to 0 is the first option 1, second option 0, third option 3, and the last one does not exist. Student, this is one of the important example, and let me clarify these points here. Fx is defined in the two different ways. Fx equal to sin x for all those x not equal to n pi. If x is multiple of pi, sin pi, sin 2 pi, sin 3 pi and so on, the value will be 0. So that means here x is not equal to n pi means what? Sin x value is not equal to 0. If x is equal to n pi, then here the function is given by 2. That means if it is pi, 2 pi, 3 pi and so on, fx is given by 2. If it is not multiple of pi, fx is sin x. And similarly, g of x is defined in the two different ways. Suppose if x value is not equal to 2, then it is x square plus 1. If x is equal to 2, then the g of x is given by 3. Then what is limit of g of f of x as x tends to 0 is given by. Okay. Student, here, one thing remember, x tends to 0 means what? X is not equal to 0. X is not equal to 0 means what? Do you remember that sin x is not equal to 0? X tends to 0 means what? X is not equal to 0. When x is not equal to 0, sin x is not equal to 0. So sin x is not equal to 0 means what is the value of fx you are going to select here? So therefore, f of x value must be equal to sin x. Student, I hope you have understood this step now. X tends to 0 means what? X value is not equal to 0. When x is not equal to 0 means what? Sin x is not equal to 0. So therefore, what must be the value of f of x? F of x must be equal to, that is sin x. Therefore, limit of g circle f of x as x tends to 0 is equal to limit of g of sin x as x tends to. Now here, when x is not equal to 0, so what is the value here? X is equal to 2. So that is limit of g of sin x as x tends to 2. So that is x tends to, like x tends to 0. Sin x is not equal to 0. Sin x is not equal to 0. What function you are selecting here? That is x square plus 1. So that is equal to limit of, it is as x tends to 0 means x does not equal to 0, that is sin x is not equal to 0. So therefore fx equal to sin x. Now what is g circle f of x here? G circle f of x is equal to, it is f of x whole raised to square plus 1 if f of x is not equal to 2. That means you are replacing x by f of x, and is equal to 3 if f of x is equal to 2. Okay. So that is equal to, now what is fx when if x is not equal to 2? It is sin square x plus 1, and if fx is not equal to 2, and it is equal to 3 if f of x equal to 2. So therefore, limit of g circle f of x as x tends to 0 is equal to limit of, now for sin x, when limit of, it is sin square x and plus 1 as x tends to 0. Means student, here x tends to 0 means what? X is not equal to 0. X not equal to 0, what function you are selecting here? Fx whole raised to square. That is sin x square plus 1. So that is limit of sin square x plus 1 as x tends to 0 equal to sin square 0 plus 1 is equal to 1. So what is the limit here? Limit is given by 1. Let me explain once again here. X tends to 0 means x is not equal to 0. So therefore sin x value is not equal to 0. So therefore the limit of fx becomes what? Sin x. Now g circle f of x means what? Here put x by fx. Fx whole raised to square plus 1 if fx is not equal to 0. equal to 3 if fx equal to 2. So that means G circle f of x, the same value is given by sin square x plus 1 if fx not equal to 2 and it is 3 if x equal to 2. So therefore limit f of x as x tends to 0 equal to this function, not equal to. So sin square x plus 1 as x tends to 0, that's equal to sin square 0 plus 1 is equal to 1 is the answer. So not equal to, and here also not equal to you are selecting. Let f of x equal to sin 2x if x equal to n pi and it is 2 if x is not equal to n pi. Okay, and g of x equal to x square plus 1. X is not equal to 0 comma 2 and it is 4 if x is equal to 2 and it is 5 if x is greater than 2, or even you can take this as say x equal to 0 you can take, or this you can take it as x equal to 2. Then limit g of f of x as x tends to 0 is, the first option here is minus 5, second option is 2, third option is 4 and the last one is plus 5. Once again student, x tends to 0 means what? X is not equal to 0. So not equal to, what is not equal to? Fx value must be equal to 2. Is it clear? X tends to 0 means what? X is not equal to 0. When it's not equal to n pi means what? It is 2. Means here if you put a pi, multiples of pi, sin value will be 0. So therefore our function is given by 2. In the earlier example this was not equal to, this was n pi, but here they are reversed line. So x tends to 0 means not equal to 0. So if this is equal to 0, this is not equal to 0 value. So our fx is equal to 2. So now limit, what function you are going to select here? Fx equal to 2 you are getting. So that means to calculate the limit, this is the value if x equal to 0, this is the value if x is equal to 2. Now we are going to calculate if x tends to 0, that means x is not equal to 0. What is the function you are going to select here? That is f of, that is x square plus 1. So that is limit of g circle f of x as x tends to 0 is equal to limit of, what is the function? X square plus 1 as x tends to 0. X not equal to 0, function is x square plus 1. So put x is equal to now as x tends to 2, that's equal to, so our function is what here? That is 2 square plus 1 is equal to 5. So limit of, here fx will be equal to 2. So because you are replacing x by fx, so that is x square plus 1 as x tends to 2 equal to 2 square plus 1 equal to 5 is the answer. If f of x equal to tan inverse of greatest integer x plus x divided by, it is greatest integer x and minus 2x, where greatest integer x is not equal to 0 and it is equal to 0 if greatest integer x value is equal to 0. Then limit f of x as x tends to 0 is equal to the first option is 1, second option minus 1, third option is 0 and the last one is does not exist. So once again here the point comes here, the greatest integer function. So when the greatest integer function is there, what you can say, limit does not exist. So this will be the answer. Now let me calculate the limit now. LHL equal to limit of f of x as x tends to 0 minus, that's equal to limit of now tan inverse of now when x is less than 0, for x less than 0, what is the greatest integer? Minus 1 plus x, and divided by here minus 1 and minus 2x as x tends to what? X tends to 0. Now let me put x equal to 0 now. That's equal to limit of, or straight you are replacing the limit now. That is tan inverse of minus 1 divided by minus 1. Is it equal to tan inverse of 1? Tan inverse of minus 1 is minus tan inverse 1 divided by minus 1 is tan inverse 1. So the left hand limit of this function is equal to tan inverse 1. Now let me calculate the right hand limit is equal to limit f of x as x tends to 0 plus, that's equal to limit of tan inverse of, now greater than 0 without crossing 0 is x of this one is 0 and plus x. Understood this step now? Without crossing 0, the greatest integer of x is 0 divided by, similarly here it is 0 minus 2x as x tends to 0, that's equal to limit of, it is tan inverse of, numerator is x divided by denominator is also x into minus 1 by 2, right, as x tends to 0. See here 0 plus x, similarly divided by 0 minus 2x, tan inverse x upon x and into minus 1 by 2. What is tan inverse x upon x? 1, and into minus 1 by 2 is equal to minus 1 by 2. So now left hand limit of this function is tan inverse of 1. What is right hand limit? It is minus 1 by 2. So LHL is not equal to RHL. So therefore the option you are going to mark is limit does not exist. If f of x equal to tan x divided by greatest integer x, if greatest integer x is not equal to 0, and it is equal to 0 if greatest integer x is equal to 0, so greatest integer x, then limit of f of x as x tends to 0 is, first option it is minus 1 by 2, second option is 1, third option is pi by 4, and the last option is does not exist. Okay, so as usual here LHL equal to limit f of x as x tends to 0 minus, that's equal to limit of, now tan of, what is the integer less than 0? Integer less than 0 is minus 1, so tan of minus 1 and divided by, it is similarly minus 1 as x tends to 0, means now straight away you are calculating, that is limit of a greatest integer x divided by greatest integer x as x tends to 0 minus, that's equal to, it is tan of minus 1 divided by minus 1 equal to how much here? That is tan 1. So left hand limit. Right hand limit, RHL is equal to limit of f of x as x tends to 0 plus, that's equal to limit of tan of greatest integer x and divided by greatest integer x as x tends to 0, that's equal to, it is without crossing this one is tan 0 divided by 0 does not exist. So the right hand limit does not exist. Therefore, the option is given for this one is does not exist. So last one more example I would like to take. The value of limit of 1 upon n plus e raised to 1 upon n divided by n plus e raised to 2 upon n divided by n plus and so on e raised to n minus 1 upon n divided by n as n tends to what? N tends to infinity. The first option is e plus 1. Second option, none of these. Third option, e minus 1. And the last option is 1 divided by e. Okay. Here we will take this one, limit of. Now shall we take 1 upon n common factor from this? 1 upon n into the bracket 1 plus e raised to 1 upon n plus e raised to 2 upon n means what? E raised to 1 upon n whole raised to square. The next term will be e raised to 1 upon n whole raised to cube plus and so on. How many terms? N terms. Because here that is n minus 1 is given and the first one is included, that is n terms. As n tends to what? N tends to infinity. Now student, is it a infinite geometric series? In this infinite geometric series, a value is given by 1. And what is the common ratio? Common ratio is given by 1 upon n. This is infinite geometric series. A is 1 and common ratio r is equal to 1 upon n. And what is the sum of this one? A into the bracket r raised to n minus 1 divided by r minus 1. That's equal to 1 into the bracket r. What is r value? E raised to 1 upon n raised to n. See here. R, e raised to 1 upon n raised to n minus 1 and divided by r minus 1 means what? E raised to n minus 1. So that's equal to, this term get cancelled, e minus 1 divided by e raised to 1 upon n minus 1. So this sum is given by now limit of 1 divided by n into, what is the sum of this one? E minus 1 divided by e raised to 1 upon n minus 1. As n tends to what? N tends to infinity. That is equal to limit of e minus 1 divided by, can you write in this way? E raised to 1 upon n minus 1 divided by, it is 1 upon n as n tends to infinity. Student, as n tends to infinity is 1 upon n tends to 0. When 1 upon n tends to 0, it is nothing but e raised to x minus 1 divided by x. So what is e raised to x minus 1 divided by x? It is log e to the base e. Log e to the base e is equal to 1. So that is e minus 1 divided by 1 equal to e minus 1. Now let me explain this once again. Assume that 1 upon n equal to x. When n1 upon n equal to x, so you are getting 1 upon n tends to 0. So this limit will comes to numerator as it is e minus 1 divided by e raised to x minus 1 divided by x as x tends to 0. That means log e to the base e. That's equal to e minus 1 is the answer. Which option you are going to mark here? That is the third option is the answer. Okay, we'll stop there today's class.